As we start working with limits in calculus, especially if we don't have our calculator, it's going to be very helpful if we know different properties of limits. So at the end of this lesson, you'll be able to use the properties of limits to evaluate limits. You'll notice we have all sorts of properties of limits. There are 5 different properties that we'll be using. You'll notice as I go through these are pretty much common sense properties, so they're nothing that you really have to memorize. You'll just kind of notice that we'll use them and know that they exist. The first one you'll notice the limit of f is equal to some limit L. It could be 5 or 6 or 8 or 2 or whatever. And then the limit of g is going to be some value k, which again could be any number depending on the type of problem. They're both having x approach c. So if that happens, you'll notice an example number in the first property. If we happen to have a function and it's being multiplied by some constant, maybe it says like 3x squared or something like that, we can find the limit as x approaches c of the function, and then we can just multiply that answer by that constant number. The sum or difference property just tells me is if I have 2 different functions, instead of adding them together first, I could find their limit separately and then add or subtract them depending on what the question called for. Same thing with the product. If I have 2 separate functions being multiplied together, I could find the limit of each one of them separately and then multiply those limits together. The next property is the quotient property. This would be if I have 2 functions that are being divided by each other, I could again find the limit of each one separately and then divide the 2. And of course, I just put that k can't be 0 because if it were 0, it would make the problem undefined. And then the last one is if I have a function and it's raised to a certain power, I can find the limit of the function and then just raise it to that power. These will mostly be helpful with if we don't have a calculator and it's easier to work with the individual functions instead of the big function altogether. So let's do some examples. Okay, you'll notice the first one, it says to use the information to evaluate the limits. We know the limit as x approaches c of f is equal to 3/2, and we know the limit as x approaches c of g of x is equal to 1/2. So in this first example, it asks us to find the limit as x approaches c of 4 times f of x. So what we can do, we know the limit of f of x, it was given to us, was equal to 3/2. And then since we're going to use, I think it was property 1, we can just take that answer and multiply it by 4. So 4 times 3/2, if you don't have your calculator, remember we'd really just put a 1 underneath the 4, and then if you multiplied across, you'd get 12 over 2, which reduces to 6. So the limit of that answer would be 6. Okay, the second one, notice I'm finding the limit as x approaches c of the 2 functions being added together. So I'm going to use the limit of each one separately first. The limit of f of x is 3/2. The limit of g of x is 1/2. And our property tells us is if we have plus, we can just add those 2 answers together. So 3/2 plus 1/2 would be 4/2, which reduces to 2. Okay, next example, we'll again use those same limits, and we'll just keep evaluating. This time it says f of x times g of x, so we know that the limit of f of x is 3/2, the limit of g of x is 1/2, and since there's multiplication, we can just multiply the 2 limits together. So again, multiplying straight across, 3 times 1 is 3, 2 times 2 is 4. So our limit is 3/4. Okay, and then the last one, we have f of x divided by g of x. So f of x is equal to 3/2, and then we're going to divide it by the limit of g, which is 1/2. And then please just remember, if I'm dividing by a fraction, it's really the same thing as multiplying by the reciprocal. And I could multiply straight across here, but I'm actually going to cancel my 2's. Cross cancel there. So 3 times 1 is 3, 1 times 1 is 1. So my limit is 3. So now you should be able to use properties to find limits of functions.